Hello everyone. So we have seen how to install Python, how to use various IDEs for Python, or how to run a Python command in a terminal. But for most of the part of this course, we'll be using Google Colab. You can find Google Colab in a Google Drive, go to New, then look for more. You can find it easily here, the Google Collaboratory, or you can, if you don't find it here, you can go to Connect More Apps and search it. So write Google Colab or simply Colab, and it's here. Okay. So we'll be making a new Colab and starting this session. So first thing we do is renaming this file. Let's rename it basic. Then we can also use this part. This is called markup language. Here we can write something. Let's say 2022 1103. That's today's date. So this is a cell where you can run a Python command. For example, if you type 2 and press Ctrl Enter or Alt Enter, it will run this cell, and anything written in that particular cell will be executed as a command. So 2 is written as 2. For here you can see the RAM and disk located to us, connected to Python 3 Google Compute Engine, RAM about 13 GB and disk about 107 GB. So let's go to a few basics of Python. The first thing we are going to look at is the print statement. Print in Python. This is not the part of the Python. Actually, it is part of the markup language. Anything that will run in this section is the part of Python. So the first thing, hello, and you can again run this command by clicking here, or Alt Enter or Control Enter. The difference between Alt Enter and Control Enter is Alt Enter will give us the extra new cell after executing this, while print, Control Enter will not give the extra cell below it. So Alt Enter is more preferable for this one. So you can use, we have used a single quotation mark here. We can also use the double quotation mark here. It will do the same thing. The difference between single quotation and double quotation lies only when we need to use quotes mark within the statement that is written inside the print statement. For example, what's your name? So here we can see it is printed what's your name, but when you use a single quote mark and write what's your name, this will generate error. So add this take WH80 and under this quotation mark, and we'll start at this quotation mark, and anything inside this range cause the error. So we need to be careful when using the single quotation or double quotation inside the print statement. So that's basic of print statement. The second thing that we'll learn is comment. Comment is anything that we don't want our compiler to execute, but we need comment. Why do we need comment? First, let's assume we have two variables doing the same thing. Let's say the age of a person is 28 and there are 28 students in a class. So this is the age of a person and this is the number of students. So if you run this, and this will assign the value 28 to age and another value 28 to student. So we can also print this age and print student. So it will print age as 28, student as 28. Or another example, number of names in class A, let's say num1 equal to 50, and class B, let's say num2 equal to 50. So that comment will help us to know what is this number 1 and num2 is all about. So we can run this. This will assign 50 to num1 and 2 to num2, but this will not execute this anything after this hash. So we can print num1, and we can also print num2. Okay, so far we have seen a comment with a single line. We can use comment for multi-line comment. So we need 3 double quotation marks, and anything we write inside this, it will be comment. So this is multi-line comment. Null lines. So now we can print. Let's print something. Let's say so we have only printed, the compiler have only printed this multiple line comments. Anything inside this 3 double quotation marks is not executed. So use comment whenever you want to indicate something, but do not run it. It's what your code is all about, what your function is all about. You can write them inside the comments. After that, we'll look at variables in Python. So variable are the names that can be assigned a value and used to reference a value throughout our code. So again, we have already seen the variables here. The age is a variable, student is a variable. So both have values 28, but both indicate different things. Similarly here, num1 and num2 are the variables, and 50 and 2 are their respective values. So to name a variable, we can use a small letter, let's say my book. And let's print it. So here in the variable, we have used all small letters. We can use all capital letters. And let's print my book. Okay. We can use a mixture of capital letter and small letters. For example, my book. We can also start with a small letter, then use a single capital letter when the word ends. So my book. So we have seen we can use letters when naming variable. We can also use underscores when naming variable. For example, my book. Close. That's fine. So mine book underscore, we can end with underscore. Again, this box, we can start with underscore. So another thing is that we can only use underscore in naming a variable. Okay. So far we have seen capital letter, small letter, and underscore in the use of variable. Apart from these three, we can also use numbers when naming a variable. Let's say my book one equal to Carnary Blues. We can use numbers in the at the end and somewhere in the middle, but we can not start a variable name with a number. For example, we can try it like this. So one my book. This generates error because we cannot name the variable by we can not use a number at the start of a variable, but we can use a number in the middle and at the end of the variable names. Apart from number, let's see whether you can use asterisk. So mine book. Again, this standards error because asterisk is used as assignment operator or as a multiplication operator here. So we do not, we cannot name a variable using asterisk. Apart from that, let's check whether you can use hyphen or not. My book. Again, we cannot use the hyphen. So far we have seen that we can use letters, small letter, capital letter, and underscore. Apart from that, we can also use numbers, but numbers should not be used at the beginning of the variable's name. And the other characters and cannot be used while naming a variable. Also, there are some words that cannot be used as variable. They are called reserved words. Normally, they will the compiler or IDE that you are using will display them in different colors. So you can see, for example, these are reserved words. They are reserved for some particular tasks or uh, previously in the Python language, so you cannot use them in naming a variable. So let's comment it out. Reserved words. There are many reserved words. You'll see them step by step later. After printing and variables in Python and comment in Python, let's look at some We'll look at basic of a string in Python. There is entire chapter in this course about the string. We'll learn most of this function, but here this is just an introduction to string. So we have already seen a kind of a string. So anything that is inside these high quotation marks are called string. Again, we can use single quotation, double quotation. Just we need to be careful not to use the sentence which contains a single quotation inside a single quotation of the string. So let's name poet kids. This is our poet. We can print it. So we can also, if there is poem, should be poet, and if there is poet, there should be poem. So ode on melancholy. Poem. So we can search whether something is inside of something or not. So let's say whether ode is inside poem or not. Since ode is inside the poem or this string, it generates true. We can also, let's see what happens when it's kept small letter. Since this ode is starting with capital, this generates false. We can also measure the length of poet and poem. So length of poet is 5 and length of poem is 17. This includes the spaces and everything. So now let's look at casting. So there are variables have types. For example, we have a string type variable. Let's say this x3. This is a integer type variable. Let's say y equal to 1. And another variable that we can have is floating type 3.25. Let's print everyone's type. So what is the type of x? What is the type of y? And what is the type of g? So type of x is string, y is integer, and z is floating point. Now what if we want to convert the everything into integer? Let's say we want to convert x into integer and z into integer. So what we need to do is x equal to, let's say, integer and x. Now let's print type x print type. Let's print only x. So previously the class or the type of the x was the string, while now its type is integer, and value is still the same, but without those quotation marks. Similarly, we can change or cast z into integer. Let's print type Z, print type, okay, print Z. So now we have converted this Z from floating point to integer. We can also convert the floating integer to floating point. So for example, let's say number 1 equal to 2, and now let's look at what type is it. So type number 1. So far it's integer. If you print it, it will generate only 2. Now if I want to convert or cast it into floating point, number 1, print type number 1, print number 1. Let's see what happens. So now after casting, the number 1 had changed to float, and instead of printing just 2, it prints 2.2, indicating that it is a floating point number. So we have just seen a few numbers in Python, that is floating point, integer, and we'll also look at other number of Python in this section, numbers in Python. So let's look at few basic number in Python. This is integer. Number 2, let's 4, or let's use the same thing. Number 3, 1 plus 1z. Now let's look at type of all these 3. So print type of number 1, copy this, type of number 2, and type of number 3. So number 1 is integer, number 2 is floating point, and number 3 is complex number because we have this j here. If we try to print everything, num1, num3, num2. So num1 is 1, num2 is 1.0, and num3 is 1 plus 1 that we have already seen here. So integer, floating point, and complex number. Apart from that, we can also assign a binary number, octal number, and hexadecimal number. Let's say this is binary number. So binary number can begin with 0, small b, and then the number. Let's name it 1100. So this is equivalent to 1 into 8 plus 1 times 4, that will be 12. We can represent it like this, or this will generate. So let's see the type of binary number. It should be integer, and if we want to print binary number, it will print 12. So this is just the representation of 12 in binary form. We can also use octal number. It can start with 0 and then O for octal. We can either use capital or small letter small o, either this O or this O, and let's say 1 1 here. So in octal number, this will be 1 times 8 plus 1, that will be 9 here. Let's look at its type. Type octal number. So it is again the integer. This is just a representation of 9 in octal form. So we want to print it. Similarly, we can use we can represent hexadecimal number. Let's say hex num. Our variable is hex underscore num 0. So instead of using adds for hexa, we use x for hexa, and again 1 1. So this will represent 1 times 16 plus 1, that will be 17. Let's again check its type. And now print it. We can also represent numbers in exponential form. So by exponential form, I mean in a form 2 times 10 to the power 2 or 2 times 10 to the power minus 2, anything. So let's say 2 times 10 to the power 2 can be represented like this. So 2 times 10 to the power 2, 10 to the power 2 is 100, and if you multiply it with 2, it will be 200. So no error there. So we look at its type. It should be a floating point number, and we can print it. So it is 200. Let's see another example. We can write 2.1615 e to the power minus 80. This is also exponential number. If you want to know its type, then it is again a floating point. And if you print it, so it is 2.1415 10 to the power or e to the power 80. Let's do a slight variation of it. So let's say we have 25.63 e to the power 2. Let's look at its type. Again, this is the floating point number. So now let's try to print it. Okay, so what it does is, so it takes this number 25.63 and multiplies it with what is e to 10 to the power 2 into 100, that is time 100, and the result is 2563. Okay, that's numbers for you in Python. Now let's look at user input in Python. So far we have only dealt with the by declaring variables here like this, and let's have a user giving a variable in Python. So user, so let's ask the user where does he or she lives. You can run this like this, but this is not so informative for a user. So what you are asking about? Let's try this. Let's name city Lima and enter. This was not so informative. We can edit this. We can write the information or ask a question inside this. Uh, Now it's little bit informative. So let's again write Lima. Similarly, we can ask for, let's say, age equal to input. So what is your age? So let's say it's 85. Now if you print this age, it will be 85. If you print this city, it will be Lima. So you have noticed that the age also come inside the two quotation marks, and Lima is also between those quotation marks. So even though we interpret naturally age as a number, but here age is a string. If you want to know its type, then age, it is a string. Type of city, it is also a string. So if you want to cast the age to integer, we can use age, int age. It will change the type of the age from string to integer. Also, we can do this while taking the input. Let's say we can cast it here, int, ask the user to give here, let's say it's 96. Now we look at type of the age, it's integer value. So taking a single input is in Python is very simple. But what about multiple inputs from the user? Let's say we want to know the two prime numbers. Let's say simply the user inputs 2 and 3. So now see what happens. So if you print num1, it will be 2, and num2, it will be 3. So we had the user have entered the input without any spaces here. So what if there was a space there? Two and 3, so this generates error. Even if the user was entering, let's say, other prime numbers such as 11 and 13, so 11 and 13, even in this manner, this will generate error. So while taking multiple inputs, it is better to use a split function along with the input function. So two numbers, split. So let's say 11 and 13 are our two numbers and no error. So num1 is 11, num2 is 13. This is what we do when we need multiple inputs from a single user. So programming is mostly used to do mathematics, and there are many mathematical libraries, and few of them we'll discuss later in this course. For now, we'll look at a few basic of mathematics here. Simple, the addition, 2 plus 2, the subtraction, 2 is subtracted by 2, 2 times 2, 2 divided by 2. The most basic mathematical concept, addition, subtraction, multiplication and division. Apart from these, we have modular division, that is, let's say 7 modular division 3. This will generate 1. So what does this mean? This means what is the remainder when 7 is divided by 3. So 7 times 2 equal to 6 and plus 1. So this 1 will be remainder when we divide 7 with 3. So that's the remainder, or that's the answer to modular division. Let's say 25 divided by 4, or modular division by 4. It's again 1. If you do with 3, it's 1. With 2, it's again 1. With 5, it's 0. Let's say 23. 25 divided modular division by 23. It will 23 times 1 plus 2. Another interesting thing is the floor division. So floor division, let's say when you divide 13 divided by 6. This is not a floor division. We'll count to floor division. That is 2.166. So what will be generated when... So if you do the floor division, only we take the output is only 2. So 13 floor division will be 2 division signs and 6. This is 2. So if 17 divides 6, it is 2.83, but its floor division will be again 2. So whatever the integer value is on the left hand side of the decimal sign is the answer to the floor division. After these basic mathematics, that is addition, subtraction, multiplication, division, floor division and modular division, let's look at power. So 2 powers 2, that is 4, 10 power 2, that is 10 times 2, that is, this is 10 power 2, 100. After basic mathematics, we'll look at the logical operators in Python. So let's say we have number 1 equal to 5, another number 2 equal to 10. So logical operators just help us in comparison. So let's say number 1 is less than 5 and number 2 is also less than 5. If number 1 is less than 5 and number 2 is also less than 5, then the statement will generate true, otherwise it will generate false. Let's check whether number 1 is less than 5 or less than 15 and number 2 is also less than 15. Since number 1 is 5 and it is less than 15, number 2 is 10 which is also less than 15, both conditions are true, the output will be true. Let's check another thing. Let's make this number 1 is less than 15 and number 2 is less than 5. So this condition will be true while this condition is false. So if any one of them is false, then it will generate false. So for AND logical operator, both condition needs to be true. Similarly, we have OR logical operator. So number 1, use the same thing again, 15, or number 2, which is less than 5. So here number 2 is not less than 5, that is 10 is not less than 5, but 5 is less than 15. So here we are using OR operator, so it will generate true. For OR operator to generate false, both conditions should be false. That is, number 1 is less than 1 or number 2 is less than 1. So in this case 5 is less than 1. So 5 is not less than 1. So this condition is false. And is 10 less than 1? No, it's not. So this is also false. When both conditions are false, the OR statement or OR operator will generate false. Apart from and OR, we have also not as logical operator. So let's see simple thing. Num1 less than 6. It is true. So anything that is true, it will be changed to false with not operator, and anything that will false will be changed to true. So now it will generate false. So other set of operators in Python are identity operators. So let's say x equal to 1, y equal to 2. So each x is y. No, because both have different values. Y equal to 1. So each x is y. Yes, it is. Another condition, x equal to 5 and y equal to x. Again, is x is y. True. Is y is x. True. If we have is, then we have also have is not. So x is not y. So this is the just reverse of what there. So other operators in Python are membership operators. We have seen a membership operator before in the string. So name, clocks, let's say on the wall. Let's say it's clock inside the name. Clocks in name, so it might generate true. Clock not in name, this will generate false. So most of the work in computer is done in binary. So we'll look at few bitwise operators available in Python. So represent x in binary number, that is 0 being, let's say 1110, and y equal to 0. We can also use capital B, 0 1 1 1. The first operator that we look at is OR operator. The OR operator is this sign. So how does this works? So it will compare these numbers. Let's say we have 1, 1, 1 and 0 for the first number, and 0, 1, 1, 1 for the second number. Now it will look at X position and compare whether either one of them is 1 or not. So 0 or 1. So this will yield 1 in OR, 1 and 1 will also yield 1 in OR, 1 and 1 same thing, 1 and 0 something. So the resulting output of this operation should be 1, 1, 1, 1. Let's check it out. X or Y. That's 15 for us. In binary, it is 1, 1, 1, 1. That is, this is 8 times 1 plus 4 times 1 plus 2 times 1 plus 1. So similar to OR operator, we have AND operator, which is indicated by this symbol. So what will be the result of AND here? So 1, 1, 1, 0, 0, 1, 0. So 0 and 0, or say 0 and 1 and will be 0, 1 and 1 will be 1, 1 and 1 will be 1, 1 and 0 will be again 0. So this will yield 0, 1, 1, 0, which is decimal number system will be 4 plus 2 equal to 6. So X and Y, that is 6. From apart from and OR, we have also XOR or exclusive OR. The output of exclusive OR is 0 whenever both bits are same, and it is 1 when both bits are different. The sign for or the operator for XOR is this operation. So in our example, 1, 1, 1, 0 and 0, 1, 1, 1. The XOR value of this is different, since 0 and 1 are different. It will give 1, 1 or 1 are same. This will use 0, 1 and 1 and same. This will give 0, 1 and 0 are different. So it will give 1. So output will be 1, 0, 0, 1. That is 8 plus 1, 9 in decimal. So X, XOR Y, that's 9 form. So after OR and XOR, we have NOT as a binary operator, but NOT is a little bit tricky. So let's start. 0 binary. Let's start with 0, 0, 0, 1. So The symbol for not is tilde. That is the sign. So what will be not of this? What is the binary equivalent of this value? It is 1. So not x will be -2. So why it is -2? Originally this had to do with how our computer stores a memory or stores a certain number inside its memory. So let's take another example. Let's y equal to 3, and then what is not y? It will be -4. Okay. So for simplicity, we can view as if we enter a positive number, the output will be that positive number plus 1 and minus, that is, if we enter 4, that will be -5, 55, then it will be -56, and so on. If we enter a negative number, then we'll get anything. A negative number will be cancelled and we'll get -1. It has to do with how computer stores a number. We'll look at later. So we have seen few operations such as AND, OR, NOT, and XOR. There are also operations like shifting towards left and shifting towards right. For this is 0 shift. Or 0. So let's again initialize a number. 0 binary, 0 1 1 0. This is equivalent to 6. So how do we shift this? This symbol means shifted to left and by 1 bit. So its effect will be this one will be shifted here, this one will be shifted here, and this 0 will be shifted here, and there will be 0 at the end. So 1 1 0 0 should be, and 1 1 0 0 means 8 times 1 8 plus 4, that will be 12. So simply shifting 1 bit towards 0 means multiplying it by 2, and shifting 1 bit towards left is dividing the same number by 2. Let's print x for a while. It's again 6. So what will happen when we shift in another direction with 1 bit? So basically what happened is we had 0 1 1 0, and now shifting everything towards right, it lost 0 0. This one will move here 1, and this one will move here, that's 1. So that is 3 for us. Let's take another example. So let's have another number 1 equal to binary. Let's make it 8-bit. 4 zeros, 1 0 0 and 1. Or for simplicity, make it 10 or 12. So this is equivalent to 12. So now let's try shifting this. Num1 shifting towards right for 1 digit will give us 24. Num1 shifting towards left, will give us 2-bit will give us 48. That is multiplying 12 by 2 or multiplying 12 with 4. Similarly, if we'll move towards right or shift towards right, num1, it will give us 12 divided by 2, that is 3, and if we'll, this will give us 3. So this is 12 divided by 2, that is 6. 12 divided by 4, that is 3. So shifting a number a bit to left will give us the effect of multiplying it by 2, while shifting it to right will give us the effect of multiplying the same number, dividing the same number by 2. So we have also other operators in Python. They are called comparison operators. We have number 1 equal to 5, number 2 equal to 6, and number 3, let's say again equal to 5. So let's compare. Number 1 and number 2 are same thing, or since 5 is not equal to 6, this will generate false. Let's use not equal to here. This will generate true. Again, we can compare whether it is greater or smaller. So num1 is greater than num2, it is not, so it's false. Num1 is smaller than num2, it is true. Another thing, num1 is greater than equal to num2. Since num1 is neither greater nor equal to num2, it's false. Number 1 is greater than equal to num3. It is true because it is not greater than number 3, but it is equal to number 3. So if there is greater than equal to, there must be less than equal to. So this will generate true as number 1 is less than number 2. Again, number 1 less than equal to number 3. So since it is equal to number 3, it is true. So we have seen less than, greater than, less than, equal to, not equal to, and greater than equal to. Apart from these, we have also assignment operators in Python. So this is simple assignment operator. Let's say x equal to 9, that is assignment operator. Y equal to x, the value of x will be assigned to y, and if you print y, it will be not. We have seen addition, subtraction, so let's look at this. Let's x equal to 5, x plus equal to 2. This is equal to x equal to x plus 2. This will generate 7. Similarly, let's say x equal to 5, x minus equal to 2. This is equivalent to x equal to x minus 2, that is x equal to 5 minus 2, which would be 3. Similarly, let's say x equal to 5 this time, x multiply equal to 2, net is x equal to x times 2, which will be 5 times 2, that will be 10. So x equal to 5, x divides equal to 2, which will be equivalent to x equal to x divided by 2, net is 2.5. Apart from these multiplication, division, we can also do other operations such as x equal to 5, x modular division equal to 5, or let's say 2. This will be x equal to x modular division 2. This will be 1 for us. Similarly, we can do the floor division, x equal to 5, x 2. This will be equivalent to x equal to x floor division 2. So x, that will be 2 for us. We can also do this with left shift and right shift. So let's say x equal to 5, which in binary is 0, 1, 0, 1. So x shift equal to 1. This means x, let's shift by 1. So shifting it by 1 means 1, 0, 1, 0, that is 10 for us. If left shift can be done, similar can be done with right shift. Now it's again 5. Apart from that, operation like XOR can be also added here. Let's say x equal to 5, x XOR 3. This means x equal to x to the power 3, or XOR 3, sorry. So this will, let's say 5 is 0, 1, 0, 1, 3 is 0, 0, 1, 1. So XOR of this will be 0, 1, 1, and again 0. So it will be 0, 1, 1, 0. That is 6 for us. So basically we have combined one operation with another and assign that final value to the x here. So later in this chapter we will see formatting output and random numbers. That's all for today.